I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, this is Algebra Unit 3, Lesson 6, talking about point-slope form of a linear function. So we're going to review first. So I have a linear function graphed here. You need to graph this in your notes. So we're going to review slope-intercept form and really just what a linear function is. So remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So the slope here is I go up 1, 2, 3, 4 over 1. So my m is 4, and my b is 1, 2, 3, 4, negative 5. So minus 5. So that would be the equation of my line, y equals 4x minus 5. Now note that it can be confusing about what is x and what is y, but this is an equation of a line, which means if I plug in a number for x, I will get a value for y out. So for example, if I say x equals 4, then I could plug in a 4. 4 times 4 minus 5 is 16 minus 5, which is 11. So when I plug in an input of 4, I get out an output of 11. So that means on my graph at 4, I would need to go up 11. So it would be here. So I can plug in any x value. Okay, so you need to understand that in order to have an actual line, I need to have those variables y and x in the equation, which represent potential values of the function. Remember, a linear function is a straight line that has a constant rate of change. That constant rate of change is the slope, which in this case is 4. Remember, if the slope is 4 over 1, if it's a number over 1, then that's actually just a whole number. So now we're going to look at exactly what is the point-slope form. The point-slope form is derived from the slope formula, which I have written here, y2 minus y1 over x2 minus x1. Now, when I say y2 and y1 and x2 and x1, I'm talking about possible points. So x1, y1 just represents a point on the line. How many points are on a line? There's an infinite number of points on a line. So that represents one of those points. And x2 and y2 represents a different point on the line. So again, those just represent points on the line, and the ones go with each other and the twos go with each other. So what we're going to do here is we're actually going to have the y's on one side and the x's on the other. So because the x2 minus x1 is being divided, we are actually going to multiply on both sides by x2 minus x1. Because when I multiply by that, then those cancel because something divided by itself is 1. So now we have y2 minus y1 equals m times x2 minus x1. This is essentially what the point-slope form is. Now, remember, in an equation, we need the y and the x. So instead of y2 and x2, we're actually just going to replace that with our y value, or our variable. So this is actually what point-slope is going to look like in your book. Pretty much anywhere you look it up, this is what you will find as point-slope form. And so in this case, the y and the x represent the variables. They represent some generic point on the line. So we would actually not plug in anything for y and x. The only thing that's going to get a value substituted for it is y1, m, and x1. Those are what I need to find. So in order to write an equation in point-slope form, I need the slope, which is m, and I need a point. Now, this does not have to be the y-intercept. It can be any point on the line. In fact, it usually is not the y-intercept, because if it was the y-intercept, you would just use slope-intercept form. So let's go back to our original line up here. And so I'm going to use this point 3, 7. So the point 3, 7 is on this line. And remember, the slope is 4. So we're going to use that. So our slope is 4 and our point is 3, 7. And we're going to find the equation of the line using point-slope form. So again, wherever you see highlighted, I'm going to plug in a value. So y minus y1 is 7 equals m, which is 4, times x minus 3. That is point-slope form. Now, what if I wanted to find the y-intercept? If I wanted to find the y-intercept, I could solve for y. And so in order to do that, I'm going to add 7 to both sides. Now notice that the 7 is going outside the parentheses, not in the parentheses. So y equals, now I can go ahead and distribute this 4. So that's going to be 4x minus 12 plus 7, which is y equals 4x, negative 12 plus 7 is negative 5, which, if you remember, is the same equation we had earlier. We just found it a different way. We found it, the slope and a point that was on the line. Now I want to take a look at this example. This is an example of an equation in point slope form, and I want to talk about how we would graph this. We can graph a line from point slope form. Why? Well, because in the equation it gives me the slope and it gives me a point. So what we have to do is we have to figure out what is the slope and what is the point. Well, the slope is 1/3, we know that. Now I need the actual point. So this value matters and this value matters. So the x value, well, there's a 2 there, but I want you to notice something. You see this plus sign here. If you remember, the equation says x minus x1. So if that is adding a number, then that means our x value was actually negative, because when I subtract a negative, I end up adding. And then my y value, it says minus 5, which means my y value must be 5 because the equation says subtract. So I'm going to go plot that point on my graph. So I have a point. Now I can use my slope to graph the line. I'm going to go up 1/3. I can also go down 1 and to the left 3. The more points you have, the better your line looks. And then you can just draw your line. So you can graph a line from point slope form. You need to know how to find the point and the slope from the equation.
I've been waiting way too long.